Use the addition method to find the simultaneous solution. Looking at the system of equations, the first thing to do is decide what variable you would like to eliminate. Remember, the goal is to have opposite coefficients. So sometimes we can inspect the system and see which variable might be easier to eliminate. So let's do that. Looking at the x's, I have the coefficient of 7 and 2. Those are not opposite numbers. Looking at the y's, I have a coefficient of -2 and +1. Those aren't opposites either. So when we run into a case like this, we're going to have to multiply either one or both equations by the appropriate number so that we can get opposite coefficients. I'm going to just go with the y's to start off with because I noticed that one of the coefficients is negative and one of them is positive. Might be a quicker way to start. I could have chosen the x's. There are other ways to go. So if you wanted to try that you should get the same solution as well. Once I make my decision on what to eliminate, I'll be clear about that. So I want to eliminate the y variable. My goal is to have opposite coefficients. So the first thing I check are, what are the coefficients? Right now the coefficients are -2 and +1. Now my goal is to have opposite coefficients. So what I have to do is find a number that both 2 and 1 go into and try to convert both or one of the coefficients so that they become opposites. So 2 and 1 both go into 2. That's the least common multiple. So my goal is to get a -2 and a +2 as my coefficient. So we already noticed that one of the coefficients is already -2, so we're not going to have to do anything to this top equation. But if we want to turn 1 into 2, we will have to multiply the 1 by 2, which would mean that this second equation would have to be multiplied by 2 on both sides so that we can modify it so that the coefficients are opposites. So our top equation, 7x minus 2y equals 0, remains unchanged. But when we multiply the 2 to both sides of the equation, we get 2 times 2x to give us 4x. 2 times y will give us positive 2y. And then we have to remember to also multiply the 2 by the constant. So 2 times -11 will give us -22. Now before we start adding our equations, we just want to double check. Our original goal was to eliminate the y variable. So please double check that your coefficients are in fact opposites, which they are, which means now you can add your equations. So 7x plus 4x will give us 11x. And as we thought, the y's can now cancel out. And 0 plus -22 is -22. So in order to solve for our x, we want to divide both sides by 11. And this will leave us with x equals -2. Once we have that answer for x, we now choose one of the original equations to plug that x value back into so that we can find our y. And it doesn't really matter which one you choose. Just make sure you're accurate when you plug them in. So I kind of noticed that I have a little bit of a mess going on here with the 2 being distributed, so I might just plug it into the top equation. So I'll choose that one. So I'll plug in x equals negative 2 into 7x minus 2y equals 0. So substituting for the x, that means we have 7 times negative 2 minus 2y equals 0. And 7 times negative 2 is negative 14. Minus 2y equals 0. Adding 14 to both sides. We will get negative 2y equals 14. And finally, to solve for y, we need to divide both sides by negative 2. So we will then get y equals negative 7. So we now have our x value and our y value. That's the simultaneous solution. And to tie things up, you'll probably want to write the solution as an ordered pair. So let's do that. The ordered pair, we always have x come first. So x is negative 2 and y is negative 7. And that is our simultaneous solution to our system of equations.